Hello, it's assignment number 5. It's about creating forecasting and about creating models. So I have chosen a data set. It's a daily climate time series in daily, that timeline between 2013 to 2017. Here you can see all the details in the kaggle.com. Let's get started. Task number 1 was about importing libraries and also cleaning up the dataset. I imported all the libraries that I needed: it's Pandas, NumPy, Matplotlib, Seaborn, Scikit-learn, and also statistical models. So I imported that one, and so initially I had the dataset already split. It's a training data, but in order to see the big picture, I concatenate it and had a one big file, and also set the index to be a date. That helps us, that help the models to actually predict and see much better than the classic 0 1 2 indexes. Here you can see the shape. It's 1100 for the 4, and head. Here is the my data. It's mean temperature, wind speed, mean pressure, and also the humidity. Here the column that I had, as I said, 4 columns, and the statistics. It's about this standard deviation, mean, marks, and all the stuff that we needed. So the interesting part is that the standard deviation is 7 in the mean temperature. So here is a visualization of our big data. As I said, I concatenate it in daily from 2013 to the 2017. Here you can see a kind of trends. It's going up and down by time. So it will be really helpful for us to see, predict, and do forecasting. And the task number 2, it's about time series analysis. So actually, we take the mean temperature of the data that we'll be using, and also started to seasonal decompose all the stuff that we needed. Here you can see in statistical model, I imported that one. So we used addictive, which actually takes the trend seasonal and precede that error and sums up all of them. It will be a other version. It's multiplicative. It will actually multiply, but as the period is like 300, we'll use addictive method. So here you take the data and split it up to the 3 categories. First one is random, then it's a trend. As you can see, it has been increasing, and the seasonal. It's like going up and down for some times. So we can see the season and some kind of errors that we have. It's actually noise. And then I trained the data. I split the data for the 80 to the 20. So the real interesting part is you have to actually take for train the first part of the data, because it's date type, and the difference between classical model, that there you can't actually take any value at random place, but here, as it is data, you actually have to take the first. We have to go to by timeline, so that's why I take to use the slicing. So I trained the ETS models for the last 1 year, and the ARIMA model for the 5 days. So for the evaluation metrics, I used mean squared error and mean absolute error. So the results are really interesting because ETS actually showed a much better result than the ARIMA. It is because we here using the last year data. That's why it's actually showing better performance. But it's kind of a cheating, but fair cheating. That's okay. So here you can see the visualization of the work that the model did. And then the task 3 is about predictive analysis. Here I created the k nearest neighbor, and the linear regression. I made the feature engineering, take the column that I need. I used all the 4 columns, and actually made some kind of log and the rolling. So then I started to split it also the data to the 2 parts, the train and test, the same thing that I discussed earlier, and just first had to actually understand to hyperparameter key what value will be the best. So as you can see in the visualization, and when key is like 15, it's showing the least error. It's actually a bit more than 2. So when setting hyperparameter for KNN models, you can just go blindly and make just some any value as key, but you have to calculate it. So I have calculated and find out that the key when key is 15, it shows the less error. So I take that as hyperparameter and then just trained and feed the models. Here you can see the results. KNN showed like 2 and 4 for mean squared error, and linear regression showed 2 and 1. The results are not actually a lot different. So let's see the visualizations. The actual data that we have, it's a black stuff. The Canaan forecast, it's blue, and the line regression forecast, it is a yellow one. As you can see, both models actually did pretty well. So that's very good. And that just residuals, it's a linear regression errors. The perfect model will be like 0 and fat, and our case it's means between -4 and 4, so it's about the temperatures. So I think it was also a nice and not very bad results. So by these we end up the assignment number 5. Thank you very much. Bye.